It works? You hear me? Thank you. I'm pleased to be here. Thank you very much for the invitation. I'm coming from the Swedish Electrotechnical Standardization Organization, and I'm the CEO. And that's not why I'm here, because that position, I don't think that is rational to be here. I'm also the chairman of the IEC Technical Committee for Fire Hazard Testing, and I think that is the reason why I'm standing here. My research in this area, I will be honest to you, is not to the public, it's to the industry. I work towards the industries and the big industries, the paper mills, the rolling mills, the mines, and there's a huge difference between fire hazard, fire risks in the industry towards the public fire hazard and fire risks. In the public, we concentrate on people and trying to extinguish the fires quick as possible. In the industry, of course, we have employees, and the safety of the employees is very, very important. But to stopping the production in a paper mill, they don't want that. It costs about an unplanned stop in a rolling mill can cost $200,000, $300,000, $400,000 an hour. So in the industry they say, okay, let it burn a little bit, as long as it don't affect the production or stop it. So it's a huge difference. We focus on material, machines, buildings, and less on people. Of course, I don't say that the employees and people industry is not relevant. They are, but they are more skilled, they are trained, and they know about the fire risks in the industry, so they are easier to handle. People in the public are more irrational, so to say. They don't do as we say. Employees usually do as they are told. So it's a huge difference. But I will try to summarize in total what we do in standardization. And if I know what will happen tomorrow, I probably will not stand here. So what I will present is a qualified guess for tomorrow, how we work in the electrotechnical area. And you can do a lot of analysis for the future of tomorrow in the electrotechnical area. In IEC, we start with the megatrends and break it down from there. And the biggest, most important companies to analyze things more or less have agreed on those different megatrends. And I don't say every megatrend creates fire hazards, so to say. So we have breaking it down a little bit to come closer to the electrotechnical area. What we see, we have a kind of IT revolution. You know, everything should be digitalized. And that is very important because it gives opportunities, possibilities. And you have heard it before in some presentation also. It's a huge possibility. Energy demand. Yeah, everything should be driven by electricity in the future. And that is also creating a kind of risk. But also possibilities, of course. And on the other hand, we talk about energy efficiency. We need more energy, but we should also save more energy. So it's kind of contradictory. But if we go to the next picture, so we see what can be a kind of future that creates some risk in the electrotechnical area. Electrical cars. Everybody knows about electrical cars. They come massive. And it creates a bit of problems. It does. It comes not for free, to be honest. You have huge battery packs. You should be able to connect, disconnect, charger in different ways. You have public charging stations which must be handled in an appropriate way. It creates risks. You have cables. You have high current. We talk about for fast, quick charging up to 100 amps, even more. And that's a huge amount of energy. If we go to the more homes area, we have this micro production of energy. We talk about photovoltaics, and we talk about micro wind turbines, for example, that you can build, you can establish on your house or on your summer house or somewhere, and that should interact with the grid that we have, and that creates also a huge problem. What happens if you have these energy possibilities and you have some fault in one of the system? How does it affect these other subsystem? It's a huge problem, so which must be dealt, and it's not easy to understand for normal people how these interact with each other. I read in IKEA in UK are starting to selling photovoltaics for homes. We haven't coming so far in Sweden, but I think the next step is that you can, for example, in IKEA, buy photovoltaics for home. And that's a question, do you also buy an electrician, or how do you combine these? I mean, it's not easy. It's not easy. But it will come. And of course, all these together, we have the DC, direct current systems. So the question is for the future, will there be two grids at home? One AC, the one that comes from the mains, and then you have your own DC grid for supplying computers, chargers, and things like that. It's not impossible. And then you have two systems that you need to maintain, combine, and so on. So, and DC current system is a bit more complicated when we talk about fires. And if we talk about high currents, it's not so easy to plug out plugs with high DC currents. It doesn't go through the serial, so it doesn't turn out of itself. Usually you have big arcs, so it's not easy. And it can create problems, but also it gives possibilities. We talk about the smart homes, the connected home. The refrigerator talk with the stoves, which talk with the stories that they need milk or something, and then you have some special deliveries for your groceries and things like that. So it also gives a lot of possibilities with this new technique and all those sensors that will in the future be built in. Everything talks to each other and you can monitor it. So, if you summarize it, you can have some of those challenging topics. So what do we do to meet these challenges? The first thing is you need to think from the beginning. Everything that you add on afterwards costs more money. The design from the smallest piece to the biggest system should be part of each other. Add-on is not good. Historically, we talk about passive fire protection. We say, okay, fine, maybe we can have a fire, but as long as it stays inside the apparatus, the container, whatever it is, it's fine. But with the development of the new electrotechnical devices, they start to cost so much. So people say, I'm not willing to let it burn. So we're going from a passive to an active fire protection. I will show you later on some ways of doing that. And of course, all these possibilities with cheaper equipment also makes a faster development. We have Earth's circuit breakers for DCs especially. We have overcurrent limitation and energy load controls. We have a lot of sensors building in. So all these together makes a system that hopefully will make the future safer. But it doesn't matter how much we build in. It doesn't matter how good we are on designing. The best and most protective way is information. Information to people. Nothing beats that. I can assure you that. I've done this for many, many, many years. I have designed fantastic things. But as I said, people are not rational. Information is the key factor. Whatever you do. So we talk about IoT technologies. You can measure whatever you want today. It doesn't cost anything, almost. And it will come more and more. When the 5G, the telecom net, will be released next year, you can't imagine the possibilities is open up. You haven't even touched the future, I can assure you. I've been at Ericsson and see. It's tactile, it's reality, you can feel it. It's delays of milliseconds. You don't know it, you don't see it. They make a test, this is out of the scope, but they make a test. They show me, they went from 2G, 3G, 4G and 5G. And they download a very famous movie, Borta med vinden. I don't know what it's in English, but with 2G, it takes, sorry? Gone with the Wind, yeah. With 2G, it almost took 20 hours. With 3G, it took 7 hours. With 4G, it took about 35 minutes. With 5G, it took 6 seconds. Then you can imagine. And when the young people of tomorrow get hold of the 5G, with the interrupt levels built in and things, it will just explode. So the future comes faster than we think of. So I said we're going from a passive protection of apparatus or devices to an active. And the way we do now in the standardization is trying to see if we can implement in the new technology these extinguished bulbs. It's a kind of liquid inside the bulbs, which is temperature controlled. You can have them from 70 degrees to 245-50 degrees in different sizes. And it reacts more or less momentarily at a certain temperature and just glows. So data centers was the first one require these. Google, Amazon, the huge one, you know, they don't accept fires. Cost whatever it will cost. They don't accept it in the data center. It's too much money. I think most of you flew in through Arlanda, the airport here in Stockholm. Every flat screen you see in Arlanda in the public area are equipped with these. It's a condition for Arlanda to set up those in the public area, to have these extinguished bulbs. So they come. The cost is today about half to €1 of those. So of course, if you do 500,000 or 10 million of samples, of course it will cost a little bit. But the protection, I think, overcomes the cost. These bulbs, just 6-7 years ago, cost about €10. So the development increases very quickly and the price is going down. The next step is to have those also in the smartphones and for the batteries. The batteries in the smartphones, the energy concentration just increases, you know. Everything needs batteries, but no one wants them. Very strange. And it's a big risk. So it will come. This is just a picture how it can look. I have movies also, but I think it's too complicated. So that's what I thought to say. Nothing more, nothing less. Thank you very much.